Hi, in this session we'll continue with the previous session of Taylor series. Okay, so we'll be doing more problems. So this is basically a problem oriented session. So we'll be taking up some new problems and also some new techniques to derive the Taylor's and Maclaurin series of given functions. Okay, so before we proceed, remember the Taylor series. What is it? So basically Taylor series is given by this expression: f of x is equal to f of x naught plus x minus x naught into f dash of x naught plus x minus x naught the whole square by 2 factorial into f double dash of x naught plus etc. And the Maclaurin series is defined at the interval as defined at the center x naught is equal to 0. So the Maclaurin series would be f of x is equal to simply f of 0 plus x into f dash of 0 plus x square by 2 factorial into f double dash of 0 plus etc. So here we will be deriving the Taylor's and Maclaurin series of many common functions using these formulas, and also we will be discussing some other easier methods to obtain the same expressions. So this is basically a problem solving session, so I suggest you also to take a piece of pen and paper and do the problems with me. Okay, so let us now proceed to the problems here. Okay, so let us now find this expression. Let's find the Maclaurin series expansion of log 1 plus x. So here first of all write down the Maclaurin series expansion. What is it? It is nothing but f of x plus f of x is equal to f of 0 plus x into f dash of 0 plus x square by 2 factorial into f double dash of 0 plus etc. Okay, so when you are being asked to find the Taylor series or Maclaurin series, at least you should have three non-zero terms. So let us try to find it out. So your f of x here is actually log 1 plus x, and your f of 0 is actually log 1 plus 0, so it is actually log 1, which is 0. And what is your f dash of x? F dash of x is again 1 by 1 plus x, or simply it is 1 plus x raised to minus 1. So f dash of 0 is equal to again 1. And what is f double dash of x? F double dash of x is equal to, if you take derivative of this, it is minus 1 into 1 plus x raised to minus 2. So f double dash of x is minus 1 into 1 plus x raised to minus 2. So it is f double dash of 0 will be simply minus 1. Okay, so what is f triple dash of x? F triple dash of x is again minus 1 into minus 2 into 1 plus x raised to minus 3. So f triple dash of x would be simply be minus 1 to minus 2, that is basically 2 factorial. Similarly, if we can observe f triple dash of x would be again, there will be factor of minus 3 coming here. So it will be minus 1 into minus 2 into minus 3 into 1 plus x raised to minus 4. So your f triple dash of 0 will be minus 3 factorial. So it will be going on like this. So what will be the expression now? The expression will simply be f of x, or log 1 plus x is equal to f of 0, 0 is 1, f dash of 0 is 1. So x, okay, f double dash of 0 is minus 1 minus x square by 2 factorial, which is again 2, x minus x square by 2. Again f triple dash of 0 is 2 factorial. So it is plus x cube by, since it was 3 factorial into f double dash of 0 is again 2 factorial. Okay, plus again x raised to 4 by 4 factorial into minus 3 factorial plus etc. So the expression will reduce to x minus x square by 2 plus x cube by 3, because 2 factorial and this 3 factorial will get cancelled out, minus x raised to 4 by 4. Okay, so I hope you can guess next time it will be simply x raised to 5 by 5 etc. So this is a standard expression, please remember that. So it's very simple, by employing the Maclaurin series you can apply it. Okay, so I hope it is clear. Okay, now I'll give you another method also. So this is the standard method, you can use this method in your examination, but there are also much easier methods. So the easier methods are based on the properties of actually the power series. Okay, so the properties of power series is basically, suppose you have a power series expansion. Suppose your f of x is equal to some a naught plus a1x plus a2x square plus etc. Okay, then the expansion of f dash of x will simply be obtained by differentiating this quantity. So there is no need to find Maclaurin series again. You can just differentiate. If you know the expansion of f of x, the expansion of f dash of x can be obtained by simply differentiating the expansion of this f of x. So it will be simply be a1 plus 2a2x plus again. So since it is a3x cube, it will be 3a3x plus etc. So the reverse also, suppose you need to find the expansion of integral f of x. Okay, to be precise, suppose you need to find the expansion of integral 0 to x f of x dx. So in that case, you just integrate these terms term by term from 0 to x. Okay, we should not use an indefinite integral, because in the case of indefinite integral there will be a factor of constant will be coming over there. So in order to avoid that, we are using a definite integral of this form. So integral 0 to x f of x dx will simply be integral of this quantity, that is nothing but a0x, okay, plus a1 x square by 2 plus a2 x cube by 3 plus etc. Okay, so if when you apply the limits, again you will be getting this quantity minus 0, so it will be 0, so you will be getting this quantity. Okay, so if you know the power series of f of x, you can easily find the power series of f dash of x and integral of f of x also. So that is another idea. So if you know this idea, okay, so I hope you are now, you know the expansion, you know that the expansion of 1 plus x, 1 by 1 plus x already we know from previous class. Okay, because you know that 1 by 1 minus x is a geometric series, its expansion was 1 plus x square plus etc. So the expansion of 1 by 1 plus x is nothing but 1 minus x plus x square minus x cube plus etc. This is from the expansion of 1 by 1 minus x by just putting minus x in place of x here. Okay, now if I integrate this, what will I get? If I integrate this from 0 to x, what will I get? I will be getting log 1 plus x. So if I integrate this 1 by 1 plus x, I will be getting log 1 plus x. Okay, so in that case again I will have to integrate this also. So what will I get? It will simply be x minus x square by 2 plus x cube by 3 minus x raised to 4 by 4. Okay, so that means the expansion of log 1 plus x is x minus x square by 2 plus x cube by 3 minus x raised to 4 plus etc., which was the same expansion which we got by using directly the formula. Okay, so this is an alternate method also. In the examination you can use any method. Direct method is easier to study, but these are also some shortcut methods through which you can obtain the Taylor series as well as Maclaurin series. Okay, the result, because the main reason here is that why you are getting the same series is that there is a result that the Taylor series and Maclaurin series are actually unique. Okay, by using that result we can say we'll get the same series by whichever way you try to expand it. You will always be getting the same series only. Using any technique if you apply, you will always get the same series only. Okay, I hope it is clear. Okay, so now let us move on to next problem, log 1 minus x, log of 1 minus x. So this also you can try using any method. The idea is just the same. You can either use the direct expansion. So direct method is, you will write the formula f of x is equal to f of 0 plus x into f dash of 0 plus x square by 2 factorial into f double dash of 0. You can use direct method, or you can use the integration method also. Okay, you can use the direct method, or you can use the integration method also. So if you use the direct method, your f of x is actually log 1 minus x, and your f of 0 is equal to log 1, which is again 0, and your f dash of x is equal to 1 by 1 minus x. So your f dash of 0 will be simply be 1. Okay, so this is same as 1 minus x raised to minus 1. And what is your f double dash of x? F double dash of x is again minus 1 into 1 minus x raised to minus 2 into again minus 1 factor would be there. Okay, so you will be getting this as your f double dash of 0 will be simply be again it is 1. Okay, so f of x is log 1 minus x, f dash of x is 1 by 1 minus x into sorry, it is there's a small slight mistake here. F dash of x is 1 by 1 minus x into again minus 1. So your f dash of 0 would be again minus 1. Again this factor of minus 1 will be there again. So when you take differentiation, it will be minus of minus 1 minus x raised to minus 2 into minus 1. So f double dash of 0 also will be minus 1. Okay, so in effective you are getting now minus of 1 minus x raised to minus 2. So when you take f triple dash of x, what will you get? Again it will be minus will be there into minus 2 into 1 minus x raised to minus 3 into minus 1 to account for this quantity. So you will be getting it as again my f triple dash of 0 will be simply be minus 2 simply be minus 2, or simply if I can write it as minus of 2 factorial. Similarly, when you take f triple f raised to 4, you will have a factor of 3 as well. So it will be minus 3 factorial. So in every term there will be minus. So your expression will become f of 0 is 0 minus x square by 2 minus x cube by 3. You can just do it yourself. The same idea only, nothing new is there. Minus x raised to 4 by 4, etc. Okay, or you can also use the integration technique also, because you know the expansion of 1 by 1 minus x, it is simply be 1 plus x square plus etc. Okay, so the integral of this quantity is actually minus of log 1 minus x, because the derivative of 1 minus x is minus, so the derivative is lying in the denominator. So when you integrate, you should be getting it as minus of log 1 minus x. So that will actually be obtained by integrating this quantity, which is nothing but x plus x square by 2 plus x cube by 3. So that means the expansion of your log 1 minus x would be simply be, you take the negative sign here, it will be minus x square by 2 minus x cube by 3, etc. So through that method also you can do it. So you can either employ direct method or easier methods also. Okay. So moving forward, let us try to now expand tan inverse x. Okay. That also I will first do it using the direct method. So tan inverse x. So I need to find the expansion. So the expansion is this: f of 0 plus x into f dash of 0 plus x square by 2 factorial into f double dash of 0 plus, etc. Okay. So my f of x is tan inverse x. So my f of 0 will be tan inverse 0, which is again 0. Okay. My f dash of x is actually 1 by 1 plus x square. So my f dash of 0 will simply be 1. Okay. This is same as 1 plus x square raised to minus 1. Okay. So my f double dash of x will be minus 1 into 1 plus x square raised to minus 2. Okay. Into 2x. Okay. So minus 1 into my 1 plus x square raised to minus 2 into 2x. So f triple dash of 0, double dash of 0 will simply be 0. Okay. So you have to be careful while doing the computations here, because there are so many terms coming. So again, f triple dash of x would be, it's a product type thing. So basically be careful. So it is minus 1 into minus 2 into 1 plus x square raised to minus 3 into 2x into again 2x factor is there. Okay. Plus using the product rule, minus 1 into 1 plus x square raised to minus 2 into 2. Okay, so when you take f triple dash of 0, you will be getting this quantity as, this will be 0, this will simply be minus 2. Okay, so that in effect, so you can find it like that. Similarly, you can find f4 of x. So the computations will become complex. So it's very simple only, but only thing is that there are many terms, so be carefully while you computing this. So when I write the expression, it will simply be tan inverse x. Tan inverse x is equal to f of 0 is 0. Okay, so f dash of 0 is 1, so we will be getting x there. Okay, similarly f double dash of 0 is 0, f triple dash of x is again minus 2, so we will be getting this as f triple dash of x is actually, so it will be plus x cube by 3 factorial into minus 2, so plus etc. So this will simply be x minus x cube by 3 plus etc. something it will be coming, so we will have to check it out. So this is one idea. Okay, or you can also use the other method, because you know that the derivative of tan inverse x is 1 by 1 plus x square. Okay, so you know the expansion of 1 by 1 plus x square from the expansion of 1 by 1 plus x. The expansion of 1 by 1 plus x is 1 minus x plus x square minus x cube. So the expansion of 1 by 1 plus x square is that in place of x you have x square here, so it will simply be 1 minus x square plus x raised to 4 minus x raised to 6 plus etc. Okay, so this is the expansion of 1 by 1 plus x square. Okay. Okay, so when you integrate this 1 by 1 plus x square, you will be getting tan inverse x. So when you, this is the expansion of 1 by 1 plus x square. So when you integrate 1 by 1 plus x square, you will be getting tan inverse x. So your expansion of tan inverse x will be obtained by just integrating this quantity, that is nothing but x minus x cube by 3 plus x raised to 5 by 5, the same as the one we obtained by the direct methods also. So in some cases, using the shortcut methods would be much easier. So if you can understand the shortcut methods, it will be much easier, or else you can directly apply the Maclaurin's formula in every case. Okay, so usually in some cases, if you know the shortcut methods, it will be much easier, the computations would be much easier, but if you can't remember, always go for the direct method. Okay, because the direct method will never fail. Okay, so moving forward, e raised to x, already we have done it before, so I am not doing it again. So in the previous lecture itself, you have found the expansion of e raised to x to be 1 plus x square by 2 factorial plus x cube by 3 factorial plus etc. Okay, similarly the expansion of e raised to minus x would be simply be minus 1 minus x plus x square by 2 factorial minus x cube by 3 factorial plus etc. I am just changing this x to e raised to minus x. Okay, so if you know the expansion of e raised to x and e raised to minus x, I hope you can find the expansion of cos hx and sin hx, the hyperbolic functions. Cos hx, you know the formula is e raised to x plus e raised to minus x by 2. So if you just add these two, you will be getting the expansion of cos hx. So when you add them, what will happen? Your negative, this odd powers will be getting cancelled out. So you will be getting this 2 plus 2x square by 2 factorial plus 2x raised to 4 by 4 factorial plus etc. Okay, so there's a factor of by 2 also. So the expansion would be simply be 1 plus x square by 2 factorial plus x raised to 4 by 4 factorial plus etc. Similarly, you can look for sin hx also. The sin hx formula is e raised to x minus e raised to minus x by 2. Okay, just subtract these two, you will be getting odd powers. So just try it out yourself. So it is x raised to x plus x cube by 3 factorial plus x raised to 5 by 5 factorial plus etc. Okay, so using shortcut methods, some problems could be done easier also. Okay, so sin hx, cos hx, again 1 by 1 minus x, already we know it is 1 plus x, it's a geometric series, 1 plus x square plus etc. Or else you can derive that formula using the Maclaurin series itself. You know that f of x is actually 1 by 1 minus x, so your f of 0 will simply be 1. Okay, your f dash of x would be 1 by 1 minus x the whole square into minus 1. So f dash of 0 is equal to minus 1. So you can just check it out how will you be getting. Okay, so it is 1 by 1 minus x the whole square. Okay, so there is a factor of minus 1 and into there is a factor of minus 1 again. Okay, why? Because this f of x is 1 by 1 minus x, or it is simply 1 minus x raised to minus 1. So when you take the derivative, f dash of x would be minus 1 into 1 minus x raised to minus 2 into minus 1. So you will be getting it as 1 by 1 minus x raised to 1 by 1 plus minus x the whole raised to 2. So your f dash of 0 will be again 1. Okay, similarly your f double dash of x also you can check it out. Now you will be ultimately getting the expansion as 1 plus x square. So please try these problems. These are very standard problems. Usually these problems are being asked in the examination. So be careful. So please try to complete all these problems. Okay. So moving forward, these are some standard expansions I am giving you for your reference. These are all obtained from Maclaurin series expansion itself, but these are very standard expansions. So these are some expansions. It should be good if you can remember. It is not necessary. You can always derive these expansions using the Maclaurin series itself. Okay. So moving forward, let us look at some other problems also. So this is one problem. Show that log 1 plus x by 1 minus x is equal to this one. So basically in these problems I will be giving you the hints only. So how will you find the expansion using, you can either use Maclaurin series directly, but in that case your derivation would be much tedious because it's a big function. But you know that log 1 plus x by 1 minus x. Okay, so log a by b is actually log a minus log b. So log 1 plus x by 1 minus x is actually log of 1 plus x minus log of 1 minus x. You know the expansion of this, you know the expansion of this. Combining them, you will be getting this expansion. Okay, because log 1 plus x, the expansion of log 1 plus x is this one, x minus x square by 2 plus x cube by 3. Expansion of log 1 minus x is minus x square by 2 minus x cube by 3 etc. So when you combine them, you will be getting this quantity. Okay, so I hope it is clear. So straight about calculation, because already you know the expansion of log 1 plus x and log 1 minus x, which you have done in the previous section now. Okay, now from that you need to find a from this result you need to find a series representation of log 2. Okay, so to do that, already you know this expression now. So your 1 plus x by 1 minus x should be 2. Only then I can use this expression to find the expression of log 2. So this quantity should be 2. Okay, in order to use this expression. Now what is if this is the case, what will be the value of x? The value of x would be 1 plus x is equal to 2 minus 2x, or 3x is equal to 1, or the value of x is equal to 1 by 3. Okay, so when x is equal to 1 by 3, your LHS will be log 2 and your RHS will be 2 into 1 by 3 plus 1 by 3 the whole cube by 3 plus 1 by 3 the whole raised to 5 by 5 plus etc. Okay, so that is another problem. Okay, so I hope it is clear. Moving forward, we will do another problem. So let us now find an approximate value of sine 85 degree correct to 4 decimal places using Maclaurin series expansion. Okay, so it's very simple. Already you know the sine expansion, or sine x is equal to, already we have done in the previous class itself, it is x minus x cube by 3 factorial plus x raised to 5 by 5 factorial minus x raised to 7 by 7 factorial, etc. Okay, so what you have to do is that you have to substitute the value of x as 85 degree. But remember, in calculus usually the angles are measured in radians, so all because the derivative is considered in that way, so the angles are always measured in radians in calculus. So you have to convert this 85 degree into radians before you use this formula. Okay, so how will you convert degree into radians? You know that pi is equal to 180 degree, so 1 degree is equal to pi by 180 radians. So 85 degree will be simply be 85 into pi by 180 radians. Okay, so use your scientific calculator to find this value. It will be approximately 1.483529 if you use a calculator. So now this is the value of x. Substitute into this formula. Okay, substitute the value of this into this formula, x in this way, and you find the values. Okay, take a first few terms. So when you do the calculation, you will be getting. So when they are asking you 4 decimal places or when something, just take a first 3 or 4 terms. When you do the calculations, as x becomes, the power of x becomes bigger, the effect of this will be nullified, the decimal places will be nullified. So you can take at least 4 terms. Okay, so directly use this here. So but remember, when you are dealing in calculus, always convert this degree term into radian, and when you use the expression, take a few terms, maybe 1 or 3 or 3 or 4 terms. Okay, so that is also clear. Okay, moving forward, one more problem I'll just tell you, I'll just explain you the method. Find the first 3 terms in the expansion of x square sine square x. We can use direct expansion using the formula, but there is a simpler method also, because you know the value of sine square x is 1 minus sine 2x by 2, sorry 1 minus cos 2x by 2. Okay, so x square sine square x is basically x square by 2 into 1 minus cos 2x. Okay, already you know the expansion of cos 2x. Cos x expansion is 1 plus x square by 2, 1 plus x square by 2 factorial, 1 minus x square by 2 factorial plus x raised to 4 by 4 factorial minus x raised to 6 by 6 factorial, etc. All even powers are coming. So the expansion of cos 2x would be 1 minus 2x the whole square by 2 factorial plus 2x the whole raised to 4 by 4 factorial minus 2x the whole raised to 6 by 6 factorial plus etc. So just substitute that formula here. Okay, and then you multiply with x square, you will be getting the required expression. That is one way. Okay, or other way, you can directly use the formula. This is your f of x. So your f of 0 will be 0. F dash of x would be 2x into sine square x plus x square into 2 sine x into cos x. So you can again take f dash of 0. So if you do that method, there will be some computational labor will be involved there. So it is better if you can use the familiar expansion there also. Okay, so these are some different problems using the Maclaurin series expansion. Okay, so now I hope it is clear. Please try these problems by yourself. Now we will move forward to the binomial theorem. It's very simple. Binomial theorem is also actually derived from Maclaurin series expansion itself. It gives you the value of 1 plus x raised to n. Okay, so this is the extension of this familiar a plus b the whole square thing. So basically this will give the binomial theorem will give the value of 1 plus x raised to n or m, whatever may be. So it is nothing but 1 plus mx plus m into m minus 1 by 2 factorial into x square plus m into m minus 1 into m minus 2 by 3 factorial into x cube, where your m is a real number. So that's the only condition. Okay, so it is defined what is 1 plus x raised to 1 by 2, 1 plus x raised to minus 3 by 4, everything could be found out using this formula directly. Okay, so there is a general formula is actually a plus b raised to m, but you have to study only 1 plus x raised to m, which is a special case of this formula, because always this one can be reduced to this formula by taking a outside. If I take a outside, it will be a raised to m into 1 plus b by a raised to m, so it will be reducing to this formula itself. So this is the expression, so please study it. It's very simple. 1 plus mx plus m into m minus 1 by 2 factorial x square plus m into m minus 1 into m minus 2 by 3 factorial into x cube plus etc. So one problem can also be asked on by the way of expand the given function in terms of this binomial series. So that is also very important. Okay, so we'll just do one problem here. So 1 plus x raised to 2. So before that, remember the expression. It is 1 plus x raised to m is equal to 1 plus mx plus m into m minus 1 by 2 factorial into x square plus m into m minus 1 into m minus 2 by 3 factorial into x cube plus etc. So write the first few terms. So this expression is this one. Here your m is actually 2. So it is actually minus 2 because this is same as 1 plus x raised to minus 2. So your expansion would be 1 plus minus 2 into x plus minus 2 into minus 2 minus 1 by 2 factorial into x square plus minus 2 into minus 2 minus 1 minus 2 minus 2 by 3 factorial into x cube plus etc. So it is 1 minus 2x, okay, again plus minus 2 into minus 3 by 2 factorial, minus 2 into minus 3 by 2 factorial into x square plus minus 2 into minus 3 into minus 4 by 3 factorial into x cube plus etc. So this is the expression. Just simplify it, so that will be your required expression. Straightforward calculation, nothing new is there, just substitution itself. Okay. Similarly, I hope you can find the value of this also. Here this is actually 1 plus x raised to minus 1 by 2. So what will be the expansion? Very simple, 1 plus mx, so minus 1 by 2 into x plus m into m minus 1, so minus 1 by 2 into minus 1 by 2 minus 1 by 2 minus 1 by 2 factorial into x square plus minus 1 by 2 into minus 1 by 2 minus 1 minus 1 by 2 minus 2 by 2 factorial into x cube plus etc. So this is the expression, just simplify it. Okay, and moving forward, another question, 1 by 2 plus x the whole cube. So first I will make it in the form of 1 by 1 plus x thing. So for that this 2 should be avoided, so I will take this 2 outside, so this will become simply b. So this is actually 2 plus x raised to 3 by 2 only. So if I take 2 outside, it will be raised to minus 3 by 2, so it is 2 raised to minus 3 by 2 into 1 plus x raised to minus 3 by 2. Now it is very easy, it is simply 1 by 2 raised to 3 by 2 into 1 minus 3 by 2, 1 plus minus 3 by 2x, 1 plus mx plus m into m minus 1 minus 3 by 2 minus 1 into x square plus etc. This will be the expansion. Just write few terms and that will be that. Okay. So this is the binomial series also. So usually one question is usually asked by asking you to expand a function term of binomial series also. Okay. So that's all. Thank you.